Okay, now let's talk about how muscle contraction occurs. Okay, so terms in whole muscle contraction. So like these are some terms that kind of go with how a group of muscles contracts. Okay, so the first term is called a motor unit. So a motor unit is the nerve fiber and all the muscles that it goes to. Okay, so there are some motor units that are really big and some motor units that are really small. Okay, so like a large motor unit would be like one neuron going to a broad group of muscles. Okay, so like muscles that you wanted to contract all at the same time that you wanted to use for strength. So maybe the muscles at the back of your calf. So it'd be like one going to a whole bunch of muscle cells. So the muscles would all contract at the same time. Now if you have a fine motor unit, it's one muscle cell going to just a small group. So that would be places where you have fine motor control, like your fingers. Okay, now muscle twitch is a single contraction that lasts just a fraction of a second. Okay, so it doesn't really last enough to have anything happen. Okay, summation, it's just like summing everything up. Okay, so summation means if we're stimulating a muscle and we stimulate it over and over and over again, the muscle contraction is going to increase until we reach a maximum. Okay, then tetanus is a maximum sustained contraction. So if you're contracting and you're holding it. Okay, and then tone, motor tone, is just continuous partial contraction of different muscle fibers, and it causes the muscle to look firm. Okay, so we have muscle tone all the time. We're just not aware of it. If we didn't have muscle tone, we would just kind of be a blob laying on the floor. Okay, now if we look at the physiology of muscle contraction, these little graphs, so there's 3 phases in single muscle twitch that you can see. Okay, so this is like the force of contraction, and then this axis, the x-axis, would be time. Okay, so if we go here, this is the latent period, so nothing's happening. We get stimulated, then we wait for contraction to occur. Then we contract, okay, and then we relax. Okay, but it's not sustained. Okay, now if you look at this axis, okay, so we have time, okay, and we have force, and you can see all the different stimuli. So instead of just one stimulus, like in figure A, we're going to have many stimuli. So what happens? So we have stimulus, then we have a little contraction, then we have another stimulus, and we have another contraction, and then we just start hit it, bombard it, hit it over and over and over again, and it sums them up, and it kind of sustains the contraction. Okay, and it'll sustain because we're just being stimulated over and over and over again until we run out of oxygen, we run out of ATP, and the muscle becomes fatigued. Okay, now muscle fibers come in 2 different forms. So there's fast twitch and there's slow twitch. And you can kind of think of it, if you think about a chicken or a turkey, and you have white meat, so you have white muscle, and you have dark meat, you have dark muscle. Okay, so the dark is the slow twitch fibers, and then the white is fast twitch fibers. Okay, and we haven't talked about this yet. This is actually on page 273 about how we use ATP. Okay, so fast twitch fibers use 2 really fast ways to make ATP. One is called creatine phosphate. Creatine phosphate is a way we store phosphate so that we can make ATP really fast. And then anaerobic respiration. Okay, so we don't use any oxygen with these. Okay, so both of them are anaerobic. Okay, they're designed for strength. They're usually light in color because they don't have much myoglobin in them. They don't have much hemoglobin in them. They don't have a lot of mitochondria. It's going to happen really fast. Okay, so they have fewer blood vessels. So this would be someone, the picture they show in the textbook is someone like lifting a weight, and it has to happen fast. Or even like a football player who's blocking. Okay, most football plays last about 5 seconds. Okay, so if you are the the defensive line and you're blocking, okay, it's fast twitch. So you're strong, it happens really fast and it's over. Okay, now slow twitch is they rely on aerobic respiration. Okay, so they're designed for endurance. So this might be a swimmer or someone who is a runner, a long distance runner, not a sprinter. Okay, so they're darker in color. They have lots of blood vessels. They have lots of mitochondria so that they can make ATP from glucose and oxygen. And they have a molecule in there that's called myoglobin. And myoglobin is a way that muscles store oxygen. Okay, so here's just a picture of what they look like. So fast twitch fibers are lighter in color. Slow twitch are darker. Okay, so slow twitch muscle fiber, it's aerobic, has steady power, so you can go for a long time and you have endurance. Okay, so this might be maybe a lacrosse player that's got to run and run and run, or a soccer player that has to run, or maybe even basketball. Okay, fast twitch is more, it should say anaerobic. It's anaerobic. They have explosive power, but they get tired easily. I don't know if football players do, but maybe. Okay, but like body or a weightlifter. Okay, now benefits of exercise. So that's on page 275. There's a big Biology Matters Health Focus. It says exercise, exercise, exercise. Sorry, guys. Okay, so the more you exercise, it increases the strength of your muscles. So it also increases your endurance. It increases your flexibility, so you're less likely to strain or hurt something. It increases the health of your heart and your lungs. And really, it gives you more red blood cells in your blood. Your high density lipoproteins increase, so that's going to improve your cardiovascular health. You end up with more protein. Your protein to fat ratio is going to increase, so you have more protein compared to how much fat. It's going to prevent certain cancers. It's going to make your bones stronger, decreases the amount of osteoporosis, makes you feel better. Okay, it can relieve depression, it enhances your mood, it helps you relieve stress. Okay, now common muscle disorders. Okay, so they're kind of written out on here, but muscle spasm is a sudden involuntary muscle contraction. They're usually pretty painful. Okay, they can occur in smooth or skeletal muscles. A seizure is if you have multiple skeletal muscles contracting, spazzing. Okay, so it can be called a seizure or a convulsion. Cramps are strong, painful spasms, usually of the leg or in the foot. It could be due to strenuous activity, but they can occur while you're sleeping after strenuous activity. They also occur a lot when you're pregnant. Strain is when you stretch or tear the muscle. Okay, so you stretch it too far. And then a sprain is when you twist the joint the wrong way. And that can involve more than just the muscles. It could involve tendons. So that could be tendinitis. It could cause bruising. It could damage the nerves. It can hurt ligaments. Okay, now muscular diseases. So the last one was disorders. So diseases, one is myalgia and fibromyalgia. Okay, so this is a chronic condition. They don't really understand what causes it, but people have just really, really achy muscles. So lots of pain, tenderness, muscles are stiff. They don't exactly know what causes it. They don't know how to treat it. They try to stop the pain. Muscular dystrophy. So this is a genetic disorder, and what happens is the muscles progressively get weaker. They break down. The muscle fibers die. Fat takes the place of them. So you can't move your body parts like you used to be able to. Okay. Myasthenia gravis. This is an autoimmune disease, and what happens with it, so an autoimmune disease is when your body starts to attack itself. So your body starts making antibodies to these acetylcholine receptors. Okay, so it first starts, they notice it in their face, first of all. So it weakens the muscles in your face, your neck, and the extremities. The last one is ALS, which is amyotrophic lateral sclerosis, which we also know is Lou Gehrig's disease. They don't know what causes it yet, but it's a really sad disease because it occurs young. So does muscular dystrophy. Okay. What happens is the motor neurons break down, and you can't control any of your skeletal muscles, so you can't swallow, you can't breathe. Okay. Once you get it, it's probably like around like 2 years. This is probably the maximum lifespan once it's diagnosed. Okay, now the homeostasis. So how do the skeletal and the muscular systems, wait, I'm going to stop here.